Hello everyone, welcome to Tech Talkies. This video is part 2 of ADF video series. I will be providing part 1 video link below the video. Today I am going to describe data integration pattern. Microsoft Azure provide a variety of data platform service that enable you to perform different type of analytics. Data integration firstly involves the collection of data from one or more sources. Optionally, it includes a process where the data may be cleaned and transformed, or perhaps augmented with the additional data and prepared. Finally, the augmented data and prepared data is stored in a data platform service that handle the type of analytics that you want to perform. This process can be automated by Azure Data Factory in a pattern known as extract, transform and load (ETL). Firstly, we will see extract. During the extraction process, data engineer define data and its sources. We have two things: define the data source, then define the data. In define the data source, identify source details such as the resource group, subscription and identity information such as a key or secret. Then we will define the data. In this, identify the data to be extracted. Define data by using a database query, a set of file or a Azure blob storage name for Azure from blob storage. Then we will see transformation. In this, define the data transformation. Data transformation operation can include splitting, combining, deriving, adding, removing or pivoting columns. Map field between data source and the data destination. You might also need to aggregate or merge the data. After all this, we will see the load. In this, firstly, we will define the destination. During a load, many Azure destination can accept data formatted as JSON file or blob. You might need to write a code to interact with the application API. Then start the job. In this, test the ETL job in a development or test environment, then migrate the job to be a production environment to load the production system. Now we will see monitor the job. In this, ETL operation can involve many complex processes. Set up a proactive and a reactive monitoring system to provide information when things go wrong. Setting up logging according to the technology that will use it. Now we will see the ETL tools. In this ETL extract transform tools, as a data engineer, there are several available tools for ETL. Azure Data Factory provide nearly 100 enterprise connectors and robust resources for both code-free and code-based users to accomplish their data movement and transformation needs. Now we will see the evolution from ETL. Azure has opened the way for technology that can handle unstructured data at an unlimited scale. This change has shifted the paradigm for loading and transforming data from ETL to extract, load and transform (ELT). The benefit of ELT is that you can store data in its original format, be it in JSON, XML, PDF or image. In ELT, you can define data structure during the transformation phase, so you can use the source data in multiple downstream systems. In an ELT process, data is extracted and loaded in its native format. This change reduces the time required to load data into a destination system. The change also limits resource contents on the data sources. The steps for the ELT process are the same as for the ETL process. They just follow a different order. Another way like ELT is called extract, load, transform and load (ELTL). The difference with ELTL is that it has a final load into a destination system. These are the two common type of data integration pattern that can be supported by Azure Data Factory. If you like my video, press the bell icon below the video and thanks a lot. Stay tuned for the upcoming video.